And friends, hello, hello, hello. It's our first time together dealing with one of our pre-calculus things. Now, before we get going into pre-cal this year, we're going to spend a real quick moment here talking about factor, because the reality is you did an integrated 2, you did an integrated 3, but chances are we probably forgot a little bit of it. So whenever we're factoring, again, we always take out our greatest common factor. Then we look for one of our special cases, and these three right here, these are the three types of special cases that you really need to worry about. Reason why is this one, these perfect square trinomials that we use in completing the square. We can get those just by factoring the remaining trinomial just like normal. So we're going to go through our 3 steps here, and we're going to see kind of how this works. Now, our first one here, we're going to have 3x cubed. And let's see here, minus 13x squared. And minus 10x. So the first thing we always want to do is look to see, can we pull out a greatest common factor? So I'm going to make my little rectangle here. Again, you don't need to do it. You can just make parentheses here and see if you can figure that out. But I'm going to use the rectangle just to be safe. It's what you guys are most familiar with as well from integrated 1 and 2. And I notice they all have an x. So I'm going to bring that x out. Now, when I bring that x out, I'm going to be left with a 3x. I'm going to have or 3x squared. I'll have a negative 13x. And I have a negative 10. So when I go through and I factor this, that x can come out, and I'm left with 3x squared in the middle, minus 13x, minus 10. Now, whenever I have 3 terms left, I automatically just jump down to factoring with the diamond and box. If there's 2 terms, then I look for one of my special cases. So I notice that I have 3 terms left. So I'm going to take these 3 terms right here, and I'm going to use the rectangle in the box off that. So let's see here. I'm going to have myself a diamond and a box. So there's my first part of my box. There's my diamond, other part of my box, and another diamond. So we're going to input all our numbers in here. So the first term, the 3x squared, that would go in the top box. The negative 13x goes in the bottom of my diamond. The negative 10, that goes in the bottom of my box. And then back we said we are going to take our first term and our last term, and whatever these are multiplied together, that goes in the top of my diamond. Be negative 30x squared. So I'm looking for 2 numbers that multiply to give me negative 30, but add up to give me negative 13. You guys, being the astute math people you are, probably realize that was negative 15 and positive 2. So those 2 terms we came up with, they're going to go actually into the box. And from there, we are going to go ahead and factor out everything. So the greatest common factor of every row and every column. So this one has just a single x. This right here would have a negative 5. And then we have a 3x squared and the negative 15x. So that's going to be a positive 3x. And positive 2, negative 10, that's a positive 2. And then we check to make sure that when I do our little Punnett square type of thing, that everything works out. So x 3x is 3x squared, x and 2 is positive 2x. And everything works out fantastic. So I take those factors and I put them together. X minus 5 and 3x plus 2. But then this is that one time where we have to remember one big thing. And for whatever reason, this seems to be the thing that people tend to always forget. It's whatever we factored out at the very beginning. Whatever we factored out that very beginning, so that x that came out at the very beginning, we need to make sure that we bring that down with us. So there actually is another x on the outside. And again, you guys did this for a couple of years. This is like old hat to you, but just in case, I think it's good to have a little review. So let's have you guys try one of these here real quick. Now also realize sometimes there is no greatest common factor. If there is no greatest common factor, hey, no harm, no foul there. Let's go minus 2x squared. And let's try a positive 56x. All right, why don't you guys pause the video and see what you can do with that. All right, so I got you all back here now. And I notice here that I got let me make my generic rectangle. Now, when I'm pulling out my number here, since my first term is a -4, I'm going to pull out a negative with it. We always really want to have that first term be positive. So I'm going to pull out a -2x. And that would leave me with a positive 2x squared here. This would be a positive x. And this would be a negative 28. So make 2x squared, positive x, and negative 28. So now, again, whatever is left over, we're going to ignore the 2x right now. But whatever is left over, that's what we're going to go ahead and use to make our drawing, make our diamond and box. As we go to finish up factoring this all the way through. All right, so I got my 2x squared here. I got my negative 28 here. Positive x. And just like we said last time, I'm going to take these two terms and multiply them together to put them on top. So if I multiply them together, I'd end up with a negative 56x squared. So I'm looking for two factors of negative 56x squared that would add up to be positive 1x. And again, that would be a positive 8x and a negative 7x. So those would go into my rectangle. And then we're going to factor whatever's out. So let's have a 2x here. I got a negative 7 here. I have a single x out there, although that was pretty sloppy. Let's try that again. There we go. And I got a positive 4 here. And friends, when we get all the way through here, we end up with 2x minus 7. And we have x plus 4. And then last and certainly least, make sure that we always bring down that negative, whatever we factored out of that greatest common factor, that comes with us. So in this case, that'd be a negative 2x. All right. So that's what our trinomials look like. And again, not all the time are we going to be able to factor out a greatest common factor. And if we don't, we just skip that. We just move on down. What happens if it's only 2 terms instead of 3 terms? So what if we have only 2 terms? Let's try to take a look-see at that one here. What about something like this? 25x squared minus 36. And again, not a whole heck of a lot changes. We always start with our first step, factor out your greatest common factor. So is there a number that will divide out from these terms? So 25 and 36, I'm looking at that and I don't see a greatest common factor. So I bring that with me. So now I'm asking myself, are these two numbers perfect squares or perfect cubes? So let's remind ourselves what a perfect square is. A perfect square, that's something where the number can be multiplied by itself 2 times. So some number multiplied by itself 2 times, that's a perfect square. A perfect cube, that's when a number can be multiplied by itself 3 times. So for instance, if I'm taking a look at some of these, I would say 4 is a perfect square because it is 2 times 2. I would say 8 is a perfect cube because it is 2 times 2 times 2. So I'm looking for either subtracting 2 squares or I'm looking for having 2 cubes. In this case, 25, that is the square root of 25 is 5. So that means if I multiply 5 by itself twice, I get 25. So in this case, I have a perfect square. 36 is also a perfect square. It's the perfect square 6. So that means I'm going to use my difference of squares formula. So what that says to do is to factor a difference of squares, we're going to write the square roots twice. So 5x and 6. I'm going to write it twice. And then if you notice, in between them, you got 1 is minus and 1 is plus. So I'm going to put minus in between one, and I'm going to put plus between the other. Now, friends, that is all we're doing on difference of squares. So when there's 2 terms, it's not too bad. You just got to go ahead and do a little algorithm, do a little shortcut here to kind of figure it out here. So what if I started you guys and I gave you guys one to try? How about 27 x to the 4th minus 3x squared. All right, friends, go ahead and pause the video here and let's see what you guys come up with. All right, so here we go again. We always look to get our greatest common factor out first. In this case, that greatest common factor, it looks like I actually have one this time. So I have a 3x, I always take out the smallest exponent, x squared. So that leaves me with 9x squared here and a minus 1 here. So we're asking ourselves now, are these two numbers perfect squares or are they perfect cubes? If they're perfect cubes, we'd use one of our sum or difference of cubes. If it's perfect squares and we're subtracting, we can use difference of squares. But it has to be one of the two. Well, in this case, the square root of 9 is 3. So that's a perfect square. And the perfect in 1 is also a perfect square because the square root of 1 is 1. So it turns out we actually have ourselves our difference of squares again. Notice, this has to be a subtraction sign. If this was a plus, we couldn't do it because it's difference of squares. It's not sum or addition of squares, it's difference of squares. So I'm going to write it twice. And then I'm going to make 1 plus, and I make 1 minus. And again, don't forget, since we factor something out at the very beginning, it has to come with us. So that also needs to be there as well. So hopefully you guys didn't forget that along the way. Whoop, and there we go. Difference of squares. All right, now, before we jump into our next one, which is going to be cubes, I want you to notice something here. Notice the plus signs. Notice the minus sign. On each of these, the very first time, this right here is always the same sign. This is always the same sign. This is plus, therefore this right here is plus. It's a minus, therefore this right here is minus. So it is the same sign. So we're going to make that an S. This right here is a minus. This is a plus. This is a minus. That's the opposite sign. If this is the minus, this is plus. That would be the opposite sign. Let's go and make that an O. And notice here at the end, it's plus and plus. Plus just means positive. So no matter whether I'm doing cubes or difference of squares, sum of cubes or difference of cubes, the last term is always going to be positive. It's always positive. So AP. So it's the same pattern, but we need to just remember SOAP, soap. So I don't take credit for that one. I picked that one up from a teacher named Miss Hodge. So we got to give her credit for that one. Got to give credit when credit's due. So she's got a little way to kind of remember these here. So let's take a look at this. X cubed plus 8. Now, I'm going to go and do my, always start off with my greatest common factor. There you go. And it turns out these right here, there is nothing that will come out of those. So there is no greatest common factor. So that means then it has to be one of my special factoring. If anything, it might not be anything. I might just have to leave it alone. So I'm looking at these here. Well, they're not perfect squares because this is a 3, but it could be a perfect cube. And it turns out it actually is indeed a perfect cube. So x cubed, that's the same thing as x times itself 3 times. So we'll call that A. This one is 8. Well, 2 multiplied by itself 3 times is 8. We already saw that a second ago. So that means 2 is a perfect cube. Turns out I have the sum of cubes. So I see a plus here. This is a plus here. I have the sum of 2 cubes. So I'm going to use my little formula. And remember, the formula is going to be a and b in the first one, a squared, ab, b squared in the second one. So if we use our little formula here, it's going to always end up being a and b in the first parenthesis. And in the second parenthesis, it's a squared. It is a times b, so x times 2. And then b squared, so 2 squared in the last parenthesis. And here's where our little SOAP formula comes into play. So since this is plus, our first one is always the same sign. So same as plus is plus. The second one is the opposite. So if this is plus, opposite is minus. And then I always end with always positive. So when I factor it, I end up with x plus 2, x squared minus 2x plus 4. So let's try a couple of these here. What if I give you guys, let's see here, 27x cubed minus 1. Why don't you guys go ahead and pause the video and see if you can actually simplify that one. Okay, so we do our greatest common factor and check to see, is there anything that will divide out of that? And 27 and 1, there is nothing. Okay, so then we're looking at it going, do I have a perfect square or do I have perfect cubes? In this case, I have a perfect cube because I do have a number that multiplies by itself 3 times to get 27. That'd be 3. 3 times 3 times 3 is 27. And b would be 1. So I have my 2 terms, and I plug them in. So 3x. So a and b. So I write the 2 terms, a and b. And then it's a squared. So I'm going to put that in parentheses. So I want to remember that I got to not just square the x, I got to square the number. Then a times b, so 3x times 1, and b squared. Time to do our SOAP formula. So same as subtraction is subtraction. Opposite of subtraction is addition. And then I always am positive. Again, you guys did this in integrated 3, so hopefully it is familiar. If it's not familiar, no harm, no foul. And it's just following a little formula there. It's not too terribly bad. So 3 squared, that would be 9, so 9x squared plus 3x plus 1. All right, friends, why don't you try and pause the video one more time and see if you can do the next one. All right, we got you back here. This time, if you notice, I do indeed actually have a greatest common factor I got to take out. I'm looking at 128 and 54, and I'm thinking to myself, I know they both have an x, but I bet I can also take out a -2. So now I have 64 x to the third, and I have a positive 27. So we have -2x, 64 x to the third plus 27. And we're only going to do now whatever was left over in the parentheses. So I'm going to ignore that 2x, only dealing with this. So do I have squares or cubes? And again, I see a cube here. That's kind of a little giveaway here. So what number times itself 3 times is 64? Well, that'd be 4. So 4 times 4 is 16, times 4 is 64. And 27, well, that was 3. I already did that one. So we're going to go ahead and do our little formula here. A, B, so it's A and B to begin with. And then we have A squared A times B and B squared. So same sign, plus, so same as plus. Opposite, so this is a plus, therefore this is a subtraction, and then always positive. But also, don't forget, I had that -2x out in front, so I'm going to go ahead and bring that down real quick. Don't want to forget that number I factored out. So then my final factors would be -2x, 4x plus 3, (16x squared) minus 12x plus 9. 16x squared minus 12x plus 9, and we are golden. All righty. Okay, that takes care of difference of cubes, sums of cubes. And then the last thing we could have, and again, I'm only going to do one of these because the reality is it's not terribly important. And we'll do it 2 different ways. And we'll call it a day. Hoping your guys' school year is off to a decent start. You had your first day yesterday. So, hoping everything is hunky-dory. There it is. All righty, friends. So the first thing we always do is we go through, and by now we should be used to this, we look for the greatest common factor. And when we do our greatest common factor, I'm noticing that a -5x can come out. So I have x squared minus 8x and a positive, actually that's a positive 8, and a positive 16. So that means we have a negative 5x x squared plus 8x plus 16. I'll have the same one over here too. All right, so here's what the shortcut is for the perfect square trinomials if you know it or if you want to use it. It said, first of all, if you notice that you have two squares, so we're only dealing with what's left inside again. So in this case, I have a perfect square here. So x squared is the same thing as x. Perfect square here, this would be my b value. Now, just so you're aware, most trinomials, again, are not perfect squares. So this is just one more thing to remember if you want to. And so what you're looking for is if this term right here is equal to 2 times a times b. So 2 times a times b. So in this case, is this equal to 2 times x times 4? In which case we'd have 8x. It really is. So that means this is a perfect square trinomial. So if it's a perfect square trinomial, what our formula says to do is take the a. So the a term goes first, so in this case it's x. The b term goes second, so here's my b value, that's 4. And I'm going to square it. The sign that goes in the middle is whatever the first sign is. So since that's plus, that means this right here is going to be plus. And again, you don't need to remember this little shortcut. It's not going to change your life in any way, shape, or form, but if you want to, you can. Otherwise, if you wanted to, which I'd probably recommend, just go back, and it doesn't take very long to go through and do our regular diamond and box. And plus, it's less to remember. No sense remembering extra things that we don't necessarily need to. But if you see the pattern, you kind of like the little pattern recognition, hey, go for it, man. Knock yourself out a little bit. Have fun with that. So I would have an x squared positive 16 positive 8x. So in other words, the perfect square trinomials, they don't do a whole heck of a lot for us. I mean, if you can identify it, great. But honestly, they don't do a lot for us because if you notice, I think we're ending up with the same thing here, positive 4x, positive 4x. It might take a little bit longer, I guess, but it's not that long. And certainly last, and certainly not last and least, we have x positive 4. And if you notice, you're going to still get that perfect square trinomial to pop out. So you end up with the negative 5x times x plus 4 times x plus 4, which is the same thing as negative 5x times x plus 4 squared. All right, so again, the perfect square trinomials, you don't need to do the shortcut. You can still do it the long way if you want to. So friends, there you go. There's our quick little review of factoring from integrated 2 and 3. Now it's your time to go out, have a little bit of fun with it here and see what you guys come up with, okay? All righty, talk to you guys later. Have a wonderful, wonderful rest of the afternoon.